Okay, so this will be a typical question we will need to use torque because it's equilibrium position, force is balanced, and then there is rotational situation as well. Okay, all right. So let's say this. First, I'm going to find out what are the forces acting. So this is something we call force analysis, and what direction they are, because then we can analyze how are they going to be balanced and how do they interact with each other, work together, right? Okay, so can you guys tell me what are the forces acting over here? Yeah, we have gravity. So where is gravity acting? Yeah, from where? Yeah, so first we got the person have a gravity going downward. That is a Fg. Let me call it Fg1. Okay, all right. And then what else forces are there? Yeah, the weight of the plank. The plank have a gravity as well. So where is the plank's gravity acting? Yeah, we always say it's acting in the middle. So that will be 1.5 meter, right? So this one is a bit smaller, so I draw a smaller one. Let me call it Fg2. Okay, and what are other forces acting? Yeah, then we got support force on both ends, right? So which end do you think is going to have a bigger support force? Yeah, B is going to be a bit closer, right? Okay, so I'm going to draw B a little bit bigger. Let me call it FB, and then there will be a FA, which will be a little bit smaller, okay? All right, so over here, before I do anything else, why don't I calculate the gravity first? That's because that's at least going to get me achieved, right? Okay, so let me say, okay, Fg1 is going to equal to M1G equal to, that's the person, 70 times 9.8. Put in the calculator. How big is that? 686. 686? Okay, sweet. Then we do Fg2. And then put M2G, that equal to 20 times 9.8. That will give me 196 Newton. Okay, and I'm gonna add these two forces, put it into the graph. That just make it easier for me because sometimes students will make mistakes. They will say, oh, I'm gonna use 20 times the distance. No, 20 is your mass. You have to convert it into force, okay? So this force now is gonna become 686, and this one become 196 Newton, okay? Any information I have, if I can, I want to put it into the graph so it's easy to see, okay? All right, so now, according to the previous question we've learned, what should you do first? Yeah, we're gonna set the pivot point, right? Okay, which point do you guys want to set the pivot point? Yeah, Jasmine, which one do you want to set? Yeah. Which point would you like to set the pivot point? Okay, we can set A or we can set B. Actually, it doesn't matter. Doesn't matter, right? Because over there, you see, we can set A or can set B, right? Okay, this one, let me say set A as a pivot point. Okay, say set A as the pivot point. And the important thing is after I set it as pivot point, and then what's going to happen? Okay, so I'm going to use a green pen to draw. Okay, that's the pivot point now. Then again, use the information we learned from yesterday. So now, let's look at the forces and the torque, how it affects. Does this one have any torque? No, this one doesn't have any torque because it goes through the pivot point, right? No torque. Okay. What is the torque of this one? What direction is this one? Clockwise. Okay. I'll say here. That gives me a clockwise one. What about this one? That's clockwise as well because it makes it rotate that way, right? And then that one is going to be, yeah, that is an anti-clockwise, torque anti-clockwise. Okay. And that's it, right? And then I know the clockwise torque will need to equal to the anti-clockwise torque, right? So that's the key to solve this question. Okay, and then I go, well, what is going to be my clockwise one? So clockwise 1, we got FG2, which is 196 times the distance. So how much is the distance? Yeah, so we need to know this distance is going to be half of the total distance 3. So this is going to be 1.5 meter. So this is going to times 1.5 meter. Okay, and then I'm going to add the gravity 1. So 686 times the distance. How big is the distance of this one? 2 meter, right? So this force is 2 meter away from the pivot. So that one is going to be times 2 meter. And both of these are clockwise, so I'm adding it together. Right? Okay, so next step, that equal to the anti-clockwise one. Anti-clockwise one is this one, FB. I don't know FB, so I'm going to write FB over here and times the distance. How big is the distance for FB? 3. That's the total distance, because this is where the pivot point is, right? Okay, that times 3. Okay, now I just need to solve this math question. So FB is going to equal to 196 times 1.5 plus 686 times 2 divided by 3. Okay, can you guys put this in the calculator and tell me how big it is? 555? Yeah. Okay. Okay, does this make sense? Okay, so now I know FB. How do I calculate FA? Yeah, 2 methods to do it. One is I can make this B point as the pivot point, so I can calculate the A, right? So which I will ask you guys to do next by yourself, because at the end you should get the same answer, right? Okay, and what is the easy way of doing it without setting B as the pivot point? Yeah, I can look at all the forces. Some forces are going up, some forces are going down, and these forces all need to cancel each other, right? Okay, so what I can do is force goes up. I'll say here, net force need to equal to 0. So that means FA plus FB will equal to FG1 plus FG2. Does that make sense? Okay, and then I can put the numbers in there. Well, FA is I don't know, plus FB 555 equals to 196 plus 686. Then I can rearrange to find FA, how big it would be. So these two add together. $327 Newton. Okay, does this make sense? Okay, so what I want you guys to do now is before you go to your homework, I want you guys to have a try. Same question, try it on the side to say set B as pivot point. Say set point B as pivot point. I want you to see if you can use that way to calculate force A. Okay, if you can do that, that means you know how to do it, and then you can start practicing some questions. And obviously, not all questions is going to look exactly the same like this or exactly the same like that one. You need to look at where is the force acting. Sometimes it's supporting it. Sometimes there might be something holding it. It might be hanging on a string with a pivot point that's hanging over there. So it all depending on the situations you have. Yeah.
When you change the pivot points, do the clockwise and anti-clockwise things stay the same?
No, they can change, yeah. Because pivot point depends. Say this one, when it's sit over here, that's clockwise. If you set over here, that's anti-clockwise. Yeah, because the force always go around the pivot point. Yeah. Okay, good question. All right.